All right, so here we are in 3.5, and here we are now graphing and solving systems of inequalities. So we're not doing systems of equations anymore, we're doing systems of inequalities. So we know that for inequalities, we have many possible solutions always, right? If we look at the graph of y is greater than negative 3x plus 5, that is this blue dotted line. Notice it's shaded above. And we can also look at the graph of y is less than or equal to x minus 2. That's this red solid line. Less than or equal to, we're going to shade below. So we kind of have this blue shading and this red shading, and we have to pick a point that applies to both of these statements. So solutions are going to be in any area that is shaded both times, twice, all right? So notice it's like kind of a purple section with the red and the blue. So I could pick a point over here, for example, 5 comma negative 1 would be a solution. I could pick a point down here, like 6 comma negative 4. That would be a solution. I could pick a point on this red line. Notice how it's on the red solid line. So this point would be 3 comma 1. That would also be a solution because it applies to both the red and the blue inequalities. Non-solutions are going to be anywhere in the blue or the red or the non-shaded regions. So for example, something up here at 2 comma 4, that would not be a solution because it's true for the blue, but it is not true for the red. All right, so it's not going to be a solution because it has to be true for both. I could pick a point down here in just the red, so negative 2 comma negative 6. That is also not a solution because it's not in the area that's shaded blue and red. And of course, I could also pick a point way out here at negative 6 comma 1 in the non-shaded area. That would be a point that is not a solution to either of those inequalities. So any of these black dots are going to be solutions, and then any of the green are not going to be solutions. If we didn't have a graph and we were just given a system of inequalities, you might be asked, is this certain point a solution? So if you think about the graph, we're trying to think, is this point going to be shaded by both of these inequalities? Well, if I plug in a 4 for x and a negative 3 for y, that would give me negative 3 is greater than or equal to negative 3 times 4 plus 4. This is the top equation here, top inequality. And so we get negative 3 is greater than or equal to negative 12 plus 4, which comes out to be negative 3 greater than or equal to negative 8. And that is a true statement, so that's good. And now we're going to look at the second inequality. We've got negative 2 times 4 plus 6 times negative 3 is less than negative 5. So we've got negative 8 minus 18 is less than negative 5. And negative 26 is in fact less than negative 5. So that is also true. So our answer to this question would be yes, all right? It has to be true for both of these inequalities in order for it to be a solution. If it's false for one or false for both, then it is not a solution. Here we're going to graph these inequalities, and then we're going to write 2 solutions and 2 non-solutions. So if I look at my first graph, we're going to do this one in blue here. We start at the y-intercept of 6, and my slope is negative 1/4. So I go down 1 and right 4, down 1 and right 4. And it is less than, so we are going to connect these using a dotted line. All right, here we go. So this is the graph here, and then I'm going to go ahead and shade below. All right, we're looking to shade below. Let me grab the blue color here. There we go. So I'm going to shade everything blue beneath this dotted line. All right, when you shade this, your graph doesn't have to be perfect. In fact, I would not color it in a dark color in case you make a mistake or in case you want to see where they overlap better. So just like a light shading will work just fine. And then we're going to go ahead and we're going to graph the second line. Now I notice this is not yet in slope-intercept form, so I'm going to divide everything by negative 2. All right, negative 2's cancel, so we get y is less than or equal to, don't forget to switch the sign, 5x minus 3/2. All right, so now I'm going to graph this. We start at negative 1.5, right? Negative 3/2 is negative 1.5. And my slope is 5. So I go up 5, 1, 2, 3, 4, 5, and over 1. I'm going to do it again, up 1, 2, 3, 4, 5, and over 1. Now this is less than or equal to, so I am going to draw a solid line. All right, and I want to do anything less than or equal to. So I think about this being a rooftop, right? Anything below the rooftop. So let me choose a red highlighter color here. And we're going to do anything less than, right? Underneath that rooftop is going to be in this shaded region over here. All right, so we know that my solutions are going to be anywhere in the area that is shaded double, right? So I want the red and the blue. So that's going to be anything in this region over here, all right? Now, obviously, the graph continues, so I could pick a point over here that would be a solution. Down here would be a solution as well. It doesn't just have to be on the grid, all right? Two solutions. Let's go ahead and write this. All right, we could pick something here, which is at 6, 0. Or we could pick something, how about right here, 0, -5. And then non-solutions, these are going to occur anywhere in the red, the blue, or the white spaces. So we could go ahead and we could actually pick a point here. All right, now we know that this point is actually not going to be a solution because it is on the dotted line. So even though it applies to the red inequality and gives us a true statement for the red inequality, it will not work for the blue inequality. So if it's on the dotted line, it is not going to be a solution. So 4, 5 is not a solution. And then I can, of course, pick anything way over here. Let's pick this dot at -6, 4. All right, -6, 4. All right, one more of these. Now in this last one, we are going to graph and write 2 solutions and 2 non-solutions, but now we are graphing 3 inequalities. So I'm going to start with the first one here. All right, let's do this one in blue. Y is less than or equal to -x. So my y-intercept is at 0, and I go down 1, right 1, down 1, right 1, right, a slope of -1. Now it is a solid line, all right, because we do have less than or equal to. So there's my solid blue line. And then I'm going to go ahead and shade below. It's less than or equal to. So that's everything in this region down here. All right. And then I'm going to go ahead and I'm going to graph the second inequality, which is x is greater than -4. So at -4, we know we're going to have a dotted line. I'm going to have these points, right, up and down. And so if we draw this dotted line, we know that greater than is going to be off to the right. So I'm going to go ahead and shade this off to the right here. And we get all these points are true for that second statement. Then we're going to go ahead and graph the last one. All right, the last one let's do in green. How about? And the green one, we first have to get this in the slope-intercept form. So I'm going to subtract 2x on both sides. That gives me -3y less than or equal to -2x plus 12. When we divide everything by -3, that gives me y is greater than or equal to, right? We divide by a negative. -2 divided by -3 is 2/3. And 12 divided by -3 is -4. So now I have to graph this. We start at -4 as my y-intercept. I go up 2 over 3, up 2 over 3, and this is a solid line. So I'm going to go ahead and draw the solid line here. And we want it to be greater than or equal to. So we're going to go ahead and shade above, greater than or equal to. It's anything above there. All right, so notice we have 3 inequalities. We have to look for solutions where all 3 of these sections overlap. And hopefully when you look at this, you can see that that is going to be in this region in the center here. This is where the blue, the red, and the green all overlap each other, okay? Remember that points on this line will be a solution, points on the green line will be a solution, but points on the red line will not be a solution here, all right? Because the red line is dotted. So if we pick 2 solutions, all right, 2 solutions, Let's say right there at -2, -2. Another one, let's pick right here at 1, -2. That would also work. And two non-solutions. Again, this would be anywhere in the area that's red, red and blue, blue and green, green, or red and green. Any of those places, you're not going to have a solution, right? Even over here with the red, just the blue intersection. So none of those places are going to give me a solution. So you can pick any points over there. Let's just pick one right there at 6, 7. And we can pick one way over here at -9, -3. All right, and there you go. So this is what you're going to see in the chapter 3.5. If you have any questions, let me know.